Hello. So this is the last chapter of this course. The last one is about regression. Regression model, linear regression, regression analysis. Anyhow, the keyword is regression. And maybe I mentioned it earlier. It's the most important topic in data analysis, economic data analysis. So let me explain. The regression analysis is to predict the value of one variable on the basis of other variables. So using other variables, we would like to explain another. For example, I would like to use the number of vaccinated people to predict the COVID cases next week, for example. Or I may use like the interest rate, exchange rates, and like other macro variables to predict the stock market tomorrow, for example. So like this kind of structure is very common in economics and also in a lot of social sciences, natural sciences, like other fields of study. So regression analysis is really important, the most important topic, one of the most important topics in economics. So I put it as the last chapter, and you will see that I'm going to apply everything we learned so far to this model. So this model is more applied, and I'm not going to introduce any new theory. Just I will explain everything as a kind of analogy, like a simple we learned estimation, we learned hypothesis testing. So the idea is based on those theory, but I will apply them to regression analysis. There may be a little bit of jump, but I think intuitively that can be understood easily, as long as you have followed the earlier chapters well. If you have, it will be summary of almost everything we learned so far. Let me start with a simple question. So in microeconomics or in micro introductory economics 110, you learned marginal cost and fixed cost, right? And suppose that the marginal cost is 2 and fixed cost is 10. For example, suppose that I am a company producing, say whatever, like natural gas, say, and the marginal cost of producing another ton of natural gas is, say, like $2,000, for example, or whatever you can think about. Like I have a restaurant, I sell like pizzas, and marginal cost of a pizza is $2, but when I open the restaurant, there must be some fixed cost, for example. So it is the standard model in microeconomics. And then given those two numbers, marginal cost and fixed cost, what is a wrong statement? Think about this. When you produce 5 pizzas, the total cost would be 20. And when you produce another pizza, then the cost increases by $2. And when you produce 10 pizzas, the average cost would be $3. And if the budget is $40, then you can make up to 15 pizzas. And all of the above are correct. So just guess, like it's not statistics question, so it should be simple. The answer is E. Everything is correct, right? So I believe it's simple enough. The reason why I'm asking you this is because if you know these two numbers, you can think about a lot of different things, and knowing the number is really important to make such a statement. And then, for example, what you can do there is, like in microeconomics, is like this. So if you have marginal cost and like fixed cost, then you can calculate like the cost function or the supply function, and then you can calculate what is the optimal production given the market price, for example, or the equilibrium. That's what you did in microeconomics. But in this course, in like statistics, we are going the other way. So like microeconomics, given marginal cost and total cost, like marginal cost and fixed cost, you derive the optimal production amount and realized cost, total cost. But in reality, we are going the other way. What we observe is how much a firm produced and how much it costs to produce them. And then from there, we do not know what is the underlying marginal cost and fixed cost. Even the firm does not know the exact marginal cost because it's too much complicated these days. So accounting problems and like inventory problems. Calculating the marginal cost is not easy, like even in a restaurant, right? So so the goal of what we are doing in economic statistics is to estimate the marginal cost and the fixed cost based on what we observed, right? For the firm, we can calculate the marginal cost and fixed cost. Then, based on those two parameters, they can optimize their quantity. Like, it's up to them. But optimization should be simple. So, as long as they know the parameters. So, what's more important, I believe, is estimation from the data, right? So, and there, it's not easy because there are errors and like noises, a lot of many things come into play in the observations. So data are not clean, and I have to ask around like a lot of different departments of the firm. So reality is more dirty, but that's what we have to do, and that's why these days many firms are looking for someone who can handle data. Handling the data is so important. Like Amazon, like Google, Facebook, they became big using their own data. So they are powerful because they have the data, and they know how to utilize the data, how to extract information from the data. That's their power. We are just learning the very basic at the entrance of data analysis. Okay, then like put it this way, we don't know, like even if you are the CEO, you may not know the marginal cost and fixed cost. So you but still have to answer those questions. When you produce 5 pizzas, what is the total cost? When you produce one more, how much total cost increases? And what is the loss if you produce nothing? Or to make the average cost equal to 3, how much do we have to produce? Or if the budget is $40, how much pizzas can you produce? Something like that. So these questions look simple, but they are relevant, important questions in practice. So as you just saw, like we need to know the parameters to answer those questions, right? And I prepared an imaginary fake data. It's the data I made up. So suppose that your firm has output and cost. This is what you observe. You observe like by month how much your firm produced and how much it costs, right? The output, say I will measure it as tons. Say you made 2 tons of pizza or natural gas, like pepperoni, whatever, cheese, you can think about any product. I will just call it pizza. So in January, you made 2 tons of pizzas. And in February, 3, and then 4, 8, 6. So each month, the output can vary depending on maybe the demand, whatever, I don't know. It is just the data. So from the data, you see the output in tons, and the cost is also measured in cost is measured in $1,000. So in January, you spent $15,000 for some reason on to operate the company, the factory, the company, the restaurant, whatever. And in February, you also spent $15,000, right? But already you have to feel something strange because you spent the same amount of money in January and February, but the outputs are different. You produced more in February than January from the same cost. I don't know why. It's just data. That's data, right? There may be errors, random errors, accounting errors, measurement errors, whatever, I don't know. And so like this, what you observe is 12 observations on two variables. 12 observations mean 12 months, and two variables are the output, amount of output, and the total cost in each month, right? So based on this data, this is what we observe. But what we do not know is the underlying marginal cost and the fixed cost. That's what we want to know. And scatter plot look like this. As the output increases, as the output increases from 0 to 10, cost increases, which is natural. Like as you produce more, the cost would increase. And there is a clear trend, increasing trend here. So you may have a trend line. That's what we actually do in a regression model, right? We would like to make a trend line, draw a trend line that go through these observations. And in mathematically, we set up this kind of model. First, we will denote the cost as y, and y comes on the left hand side because this is what we would like to explain. The final goal of this analysis is to predict, estimate, forecast the cost. So like if I produce this much, this would be the cost. So we would like to calculate that cost function, right? So the left hand side is the output cost, and the right hand side includes first output, which is x, and of course this is by month, and beta 0 is fixed cost. So cost starts from beta 0, even if you do not produce anything. Even if x equals to 0, the cost is beta 0. And beta 1 is the marginal cost, which means as you increase the output by 1 unit, then beta 1, the cost increases by beta 1. So this is the slope, which is the marginal cost. For each unit output, cost increases by beta 1. And then finally, we have epsilon. So this is Greek letter, epsilon. Epsilon is an error term. It's an error, purely an error. It's a random error. So again, in sum, we would like to explain the cost using two parameters in fixed cost and marginal cost, and the output and error, right? Here, there are 5 objects, but you have to tell what is what and what is random, what is observed, what's not. First, the only 2 variables that we observe are y, the cost, and the output x. So that's what we have from our data, remember? And the unknowns are, of course, the others are unknown. Beta 0, beta 1, epsilon are unknown. But now, on the other hand, you have to tell what is constant and what is random. The total cost and output are random because every month they may be different. And also the random error, epsilon, is random because error can be different from in different months, right? However, the fixed cost and marginal cost are constant. Even if they are unknown, we assume that there is a true value, one fixed true value, which is consistent with the idea of parameter. So when we define the parameter in estimation chapter, we assume that a parameter should be constant because we are guessing that, so it is the target of estimation, so it should be fixed. If it's random, then the estimation problem is not well defined. So in this case, fixed cost and marginal cost are fixed. So those two are unknown parameters, and epsilon is just a random error. It is unknown, it is random. We are not interested much in this error term. Just it's included because there are errors. And in the end, we would like to estimate the parameters beta 0 and beta 1 using data on x and y, using observations on x and y. That is a basic setup of a linear regression model. Okay, I'm going to continue this explanation in the next video. Okay, see you later. Bye.